Hi guys, welcome to ITI1120, Lab 5. Today we will learn lists, range function, loops, pointer variable, and aliasing. Be careful that this is a very important lab. Please make sure you learn and understand all of its materials. Let's start. For today's lab materials, you can find them in the browspace. And the file is named Lab5 students.zip file. Please download this zip file and unzip it. Before starting, please make sure that you are running Python 3. For today's tasks, please do all of them in your head firstly, on a paper. And then if you want to verify your answers, you can copy or paste the code to the Python shell to verify your answers. This is today's first task. What does this print? In the first line, we assign this is a string to the variable s1. Then we assign this is a string to variable s2. After that, we assign the variable s1 to the variable s3. So here, variable s1 and s3 are aliases of each other, and both of them point to the same object in memory. So if we check whether s1 is equal to s3, here we use the double equal operator. It means that we want to check whether the values in s1 is equal to the values in s3. Since both of them point to the same object in memory, and this is a string, the values are all same, so this will return true. Well, after this, we assign AHA to the variable s1. So recall to the last lab, we have talked about that string is immutable. Every time we have created, after we have created it, we cannot modify it. So here, what it means is that a new string object which contains the value AHA is created. So for now, S1 refers to the new string object, while S3 still refers to the original, the previous string object, which contains the value this is a string. So if we compare the values of S1 and S3, now S3 is still this is a string, but S1 is AHA, so this will return false. And here, S2, it contains this is a string, while S3 contains this is a string also. So it will return true. Let's try this together. Firstly, we initialize S1 as this is a string, and then S2 as this is a string. After that, we assign variable S1 to S3. Then we want to check whether S3 is equal to S1. Here it is true, because both S3 and S1 points to the same object in the memory. We can check this using the ID function, which will print the memory location of the object. We can see that both S1 and S3 points to the same memory location. But after this, we assign string AHA to the variable S1. Then we can see that the memory location of the variable S1 points to changed. So here, if we compare S3 and S1, it is false, because S3 is still contains the value this is a string, but S1 now contains the value AHA. And also we can check that the location of S3 points to is still this one. However, the object location the variable s1 points to has changed. We can also compare the values of s1 and s2. They are same because both of them contain this is a string. The values are same. Well, here we can learn that we can use a double equal sign operator to compare the values of two variables. Well, next, what does this print? S1 is this is a string, and then we print this line. After that, we print the type of S1. So S1 should be type string. Then S4, it is a list with only one element, which is a string. So the type of S4, it should be a list. And then we print the type of S40. S40 means the element in the index 0 of the list S4. It is a string. So the type of it is a string. You can verify this in the Python shell. Next task, what does this print? S5 is a list. S6 is also a list. And you can see that all elements in S5 are same with elements in S6. So if we check whether the values in S5 is equal to S6, it should be true. However, if we use is to check the memory location of the variable points to whether they are same or not. Here, even though the values of the list are same, however, for each variable, it points to a different object. So the object is in different location. So if we use is to check it, it will return false. And then we assign the variable s6 to s7. So here we use the aliasing. Both s7 and s6 are the aliases of each other, and they both point to the same object in the same memory. So if we print s6 is s7, it will be true. After that, we change the element in the index 3 of s7 to false. So recall to the previous lab, list is mutable, which means that it supports in-place assignment. So for now, s7 and s6 points to the same object in the memory. Well, if we change the elements in the list s7, which is modify the object s7 points to, same with the i6, the variable i6. The variable i6 is also points to that object, and that object is changed. So i6, if we print x6, it is also changed. So we will see that i6, it will be 2, 4, and this string and false. And s7 will be 2, 4, this string and false. While if we print s5, it's not changed, because s5 points to a different object with the other two variables, i7 and i6. So s5 will still be 2, 4, this string, and true. We will try this together. First, we can check whether i7 is equal to i6. Here we use a double equal sign. We want to check the values of them, whether they are equal. Yes, it's true. And then we want to check whether these two variables point to the same object in the memory. It's also true. We can also verify this using the ID method. Back here, they are same, right? And then we want to change the s7, the index 3 to false. Here, because list supports the in-place assignment, so in the same memory location. the third elements, the elements in the third index is changed to false. We can see that. Let's print S7. Let's print S6. So both S6 and S7 point to the same memory location, so both of them have changed. But here, they are both of them are false. You can also check the memory address of these two variables. They are same. And then you can print S5. S5 is not changed because S5 points to a different object with S6 and S7. So here you can see that we use double equal sign, this operator, the equality operator, to compare two values of the variable, while we use is to compare the memory address of two variables, whether the two variables point to the same object in the memory. So be careful with them. Every time you want to compare two values, you use the equality operator. Every time you want to compare the identity, the memory address, you use the is operator. Study the following four fundamental algorithms. Return sum of all positive integers smaller than n. Here in this function, the function is named summation, and it accepts one parameter n, and the type construct is number. N is a number, and the return type is also a number. So outsum is equal to 0. So first we create a variable named outsum and we assign 0 to it. After that we write a for loop in range n. Then we add num. We add all the positive integers from 0 to n-1 to the outsum. Then finally we return the outsum. And returns a product of all positive integers smaller than n. So for this one, we change the plus operator to the multiplication operator. And also, initially, we assign 1 to the variable prod. Next is the sum of numbers in a given list A, a solution with loop over elements. Here the function is named SumList v1, and it accepts a parameter which is a list. A is a list, and the function will return a number. Firstly, we assign 0 to the variable list sum, and then we write a for loop. For each element in the list A, we add the element to the variable list sum, and finally we return the list sum variable. Sum of numbers in a given list A, a solution with a loop over indices. So here, for this one is to loop over elements, while for this one is to loop over indices. You can see that for the indices, I is index, and it starts from 0 to the length of the list A-1. Okay, please study these four algorithms. You will use them in the labs or assignments. Task 4 and programming exercise 1. Okay, this is the first task and today's first exercise. After studying the previous four fundamental functions, how would you modify them to only sum odd numbers or odd list elements? Try yourself and then see next step for solutions. So here you need to check whether the numbers are odd or not. You need to write an if statement. Open the file called forfunctions.py, copy or paste one by one example 1 to 4 into the Python visualizer. Run through each example and understand how the solutions work and how the variables change in the loops. As always, you can find Python visualizer here. make sure you choose Python 3. You can find the Python visualizer in this link. And then today's first exercise. Write a function called AH. It accepts 3 arguments, L, X, and Y. That's given a list L. L is a list. An integer X and Y such that X is smaller than or equal to Y. Returns 2 numbers. So the function returns 2 numbers. The first is the number of elements of L that are between X and Y, including X and Y. The second number is the minimum element of L that is between X and Y, including X and Y. So here is an example. The list is this, and X is 2, Y is 11. So the function will return 3 and 5. There are 3 elements that are between X and Y, 5, 10, and 8. And the smallest number that is between X and Y is 5. Recall that you can return 2 numbers referred by variables A and B by just returning a tuple. So here in the return statement, you can write like return bracket, the first variable you want to return, and comma, the second variable you want to return. Okay, this is today's first exercise. Next, task 5. How many stars does the following program print? So for I, start from -2 and ends in 13. Every time we add 1 plus I, we add 1 to I. So I will be -2, -1, 0, 1, 2, 3 until 13. So those lines will be executed 16 times because there are 16 values for I, and those 2 lines will be executed 16 times. Each time it will print 3 stars. So 16 times 3 is 48. So there will be 48 stars. Next is the print function. The built-in function print, when it completes printing, enters a new line, for example here. So the print function by default, it will end with a new line. Here we print this, then it will enter the new line, then print Lab5, like this. But as mentioned in the last lab, this default behavior of the print function can be changed by specifying what we want print function to end with. For example, we can change the end parameter to anything else. Like we can say that we don't want to end with a new line, rather than we want to end with 3 star sign here. So in this print line, it will print this, and then 3 star sign is this part. After that, it will print Lab5. Then the end parameter is not be specified. So by default, it will end with a new line. So then print Lab5, and there is a new line. After this, it will print this. Then it will end with a no space. End in the same line, but with no space. Here we can see that it will print this. And after this is Lab6. We can see that there is no space between this and lab. And then here we specify that end with a new line. This is a new line character. So Lab6 and then a new line, and then print this. Here this is end with a space. So we print this is end with a space, and then Lab7, and then a new line. So in other words, unless specified otherwise, the default end for the print function is end with a new line, is this one. This is the default one. If you don't specify the end parameter, then it will print by default. It will end with a new line. There are more examples for the print function. Function print prints by default a new line character after after printing its arguments. Here is a list named pets, and we iterate the list, write the for loop over the elements in the list. Then we print the elements. We didn't specify the end parameter, so it will end with a new line, like this. And here we specify end with a comma and a space. A comma and a space here. We can see that it ends with comma, space, comma, space, comma, space. Here are 3 exclamation points and with a space. You can see this. The end argument allows for customized end characters. So here you can change anything you want. Task 6. What does this print? Fruits. There is a list named fruits, and we write a for loop over the elements in the list. Then we print the elements, which is the variable a fruit, and end with a space. What does this print? Is to loop over index and end with a space also. What does this print? It will print hi. Each time it will print hi name. Name is Joy. Joy, please come to my party on Saturday. After that, it will be a new line, and then print next line. You can try this in the Python shell. And task 7, what does the following program print? Here we can see that I will start from 5, and every time we add -1 to I. So initially, I is equal to 5, then num is equal to 1. After this, there is a nested for loop. For j in range 1, 6, so j will be 1 to 5. We print num and end with a straight line and a space. And then we assign num times 2 to num. So every time we iterate over all elements in this range, execute those lines. Then we jump out this nested for loop. We start the next iteration of the outer loop. Here, every time we jump out from the nested for loop, we will print an empty line here. Then we start the next iteration of the outer for loop. This is task 7. Today's programming exercise 2. Experiment with perfect numbers. A positive integer is called a perfect number if it is equal to the sum of all of its positive divisors, excluding itself. For example, 6 is a perfect number since 6 is equal to 1 plus 2 plus 3. The next is 28. There are 4 perfect numbers less than 1000. Write a program that prints all these 4 numbers. Your program should have a function called isPerfect that takes as input a positive integers and returns true if it is perfect and false otherwise. So your function accepts an integer and returns true or false. Remember that here it is return, not print. So your function should return true or false. Once you are done, modify your program so that it looks for all perfect numbers smaller than 35 million. What do you notice? Assuming that your computer can do 1 billion instructions in a second, can you figure out how long, roughly, will it take your computer to find 5th perfect number? The answer is roughly, like couple of minutes, couple of hours, couple of days, weeks, months, years. You can try to think about it's like the time complexity of the function. Exercise 3, the first part. arithmetic progression. Recall that a sequence of numbers forms an arithmetic progression if the difference between every pair of consecutive numbers is the same. For example, -5, -1, 3, 7, 11 forms an arithmetic progression since the difference between every pair of consecutive numbers is 4. On the contrary, this one is not an arithmetic progression since the difference between some consecutive pairs is 5. Like here is 5, but here is 4. So a sequence that has exactly one number is considered arithmetic too. Write a function called arithmetic that takes as input a list of numbers and returns true if the numbers of the list form arithmetic progression and false otherwise. Here are some test cases. Well, for this one, you can write a for loop and then compare the difference between each pair of elements. Like you can compare the first pair of the elements, what's the difference of them, and whether the second pair of elements is same as the first pair of elements, is same as the difference of first pair elements. If they are same, continue until the end of the list. Well, if it is not same, you can just return false. Like the difference between these two is -1, but the difference between these two is 4. So when you check the difference between this pair is not same with the difference between this pair, then you can return false immediately. Okay, next part, now modify your method arithmetic selectly so that instead it tests if the numbers in the given lists are ordered from smallest to largest, called the new function is sorted. So for this one, you need to create a function named isSorted and accepts a list here, and it will return true or false, whether the list is sorted or not. Wow, this one is very similar with the previous one. Previous one, we need to check the difference between the consecutive pairs of elements. Well, this one, we just need to check whether the two consecutive pairs of elements in the list is in order. If yes, continue check the next pairs of elements until the end of the list. Well, if it is not, like here, we check that 0 is smaller than 3. Okay, but here 3 is larger than 1. It's not in order, so we can return false immediately. Okay, task 6. You can check this link to do some multiple questions. You can do them yourself, and if you have any questions, you can ask TA for help. I think that's all for today's lab. Hopefully you can understand all the materials for today's lab because it's very important for your exams, assignments, and labs. Okay, that's all for today. Thanks for listening. Bye.